Actually, today the last, sorry, yes, I think last 2 days, right? We already finished for transformer. Okay, so we will continue on chapter 5. Okay, so before we continue, okay, I want you to ask a few questions. Okay, from transformer topic. Wait, hmm, I need to have to put this 29864. 29864. 9864. Okay, you can try to join. I give you like 3 minutes to join, then we continue on the next lessons. Oh, 5.1 we already done, huh? Yeah. Yes. 5.1 we already done. Yeah. So we can go to 5.2. 5.2 semiconductor. Okay. So let's see how many of you already joined. Okay, I want you to answer. Only 3 people only. Where's the rest? Right. So we just continue. You can still join even the quiz is already start. Okay. So question number 1 until number 4. I give you 3 minutes, 4 minutes only. 4 minutes for each question. 4 minutes for 4 questions. Okay, 1 people already answer. So tomorrow we do not have class. So tomorrow is Sunday, right? So we continue on Monday, and after then so on lah. And then tonight class is will be a revision. I think I already give you the questions, right? The past year questions. So we will discuss that one. Okay. Okay. 15 second more. Okay. Stop. All right. So let's discuss the questions. Okay, the diagram shows a circuit containing an ideal transformer. So what does it mean by ideal transformer? Means the power input is same as the power output, right? So means there is no loss of energy. Okay, there is no loss of energy. So it says here which statement is correct about the brightness, okay, for bulb P and bulb Q. Okay, so this one it is a step down, right? Okay, this is a step down transformer. Okay, this is a step down transformer. Okay, so it means the voltage will be dropped, right? But here the voltage, yeah, the voltage will be dropped. Okay, so means the bulb P, okay, will be brighter than bulb Q. So the answer is A. Hmm, wait, oh, correct. I don't know why I cannot write it too far here. Okay, A. Okay, the purpose of using the laminated iron core in a transformer. Laminated iron core is actually to reduce the AD current, right? Where you learn that if you put it, let's say, in a block like that, okay, so the AD current will be, the whole block. But let's say you put it in the laminated, right? It means a layer of the iron core. So the AD current will be reduced because this becomes smaller, right? It becomes thin. Okay. So the answer is B boy. Okay, the answer is B boy. Okay, and why is the core of a transformer made of soft iron? So soft iron is actually is easy to magnetize and demagnetize. Okay, so the answer is D donkey. I don't know what happened to my board. Okay, so this one the answer is D. Okay, the diagram shows the structure of an ideal transformer. What is the potential difference, okay, across the bulb? Okay, so for this one, we can use, okay, they give you what? They give you the VP, right? VP and also NP. And then NS, okay, secondary, okay, they ask you to find the VS, okay. So potential difference across the bulb is VS, okay. The potential difference that actually for the one that supply the current is VP, primary, okay. So I just like told you 2 days ago, let's say if it which one you don't know which one is primary, secondary, so you just see which part, let's say this part that give the let's say for the AC current. Okay, you see this one, they got AC current. So AC current means they supply the current, electric, right? So that one will be the primary, and then there will another part. Okay, let's say on the right part. Okay, for the transformer, you see the bulb there or electrical appliance. Sometimes they put other, not just bulb. Okay, so that one must be secondary, or output. Sometimes they put input. Input output also same. Input primary, output secondary. Okay, so we already know, right? If this one mean they use NS over NP is equals to VS over VP. Okay, so NS is 20 and NP is 80. Okay, and VS is the one that you need to find, and 240. So 240 times 20 is 400, 4,000, 48, 84,800, right? Okay, and divide by, so the answer is D. Okay, so you just can cross multiply. Okay, so the answer is A, B, D, D. Mhm. Very good. All right. So we move on to the next topic. Okay, so 5.1, I already noticed that we already learned that one. Okay, so I will go to 5.2, that is a semiconductor diode. Okay, so 5.2, semiconductor diode. All right. We on 5.1, right? We already learned about the CRO, right? Cathode ray oscilloscope. We already learned about the thermionic emissions, right? When the metal you give the heat to the metal, then when they got enough energy, they will go out, okay, from the metal, okay, and there will be flow of electrics there. Okay, and we already learned about the multi-cross. Okay, and the multi-cross can deflect by the magnetic fields. Okay, so that one we already learned. You can see, I think I put the recording of the video in the YouTube. And for the 2 days ago also, I still didn't put, so I will put it together with today's lesson. Okay. All right. So the next one, this is a semiconductor diode. Okay. Um, and what is actually semiconductor diode? Okay, so this is the earlier model of television and the radio. Okay, during 1960s one, right? So this is the type of television, right, that I have. Okay, so the one, the thick one, right? Now you are using the thin one, and then the quality of the picture is much better. Okay, and we use this kind of radio. Okay, we don't have the airport or something like that during that time. Okay. Okay, so what can you say about the size of the televisions and radio? Of course, the size becomes smaller, right? Or become thinner. Okay, so this is the diode, right? So earlier model of television and the diode and a radio. So this is a vacuum diode. Vacuum means there is no air inside. Okay, and this is a diode. Okay, for the earlier model of televisions. Okay, now is the newer one. Okay, so television and radio is just the same thing. Okay, but it much, I think, much complicated, right? Okay, so you put it in the board. So this is the IC. Okay, can you identify some of the components? Yes, some of, maybe there's a diode here. Okay, PNP, NPN, right? You see, this one I think you already learned in the RBT, right? In the electricity part. Okay, and materials can be classified in terms of their ability to conduct electricity. Okay, so some materials, if they can conduct electric, we call it as a conductor, right? Such as metal, cuprum, um, aluminium, right? So anything that can make the electric flow through it, we call it as a conductor. Or sometimes not just electricity, sometimes heat also. Okay, so heat. And then the insulator, something that some materials that cannot make the current flow through it. Okay, so let's say woods. Okay, um, I don't know what to say. Yeah, this one, suddenly I forgot the word. Uh, Rubber, yeah, rubber. Okay, yeah, that one cannot close electric, so we call it as insulator. Okay, or plastic, you know. And what is the material that actually that can conduct it also, but it's not good as the conductor. It can still conduct the electricity, but it's not good as a conductor. Okay, so we call it as the semiconductor. Okay, so it can flow electric but not as good as the conductor, because conductor all the electric can flow through it, but maybe for the semiconductor only half of it will be allowed to flow. Okay, so this is a conductor. Then when a potential difference is applied across a conductor, electron will move in the same direction towards the positive terminal and the current is produced. So I already mentioned just now about when you learn chapter 4, right? I told you that actually the current is from the electric. The electron will move same towards the positive terminal. Towards the positive means from here to here, right? And the current will produce. Okay, so what is the semiconductor? Okay. So semiconductor is a material that has a resistance between the conductors. Okay, maybe you can make this one correction. Between the conductors and insulator. Means the behavior, okay, the behavior of the semiconductor is actually between conductors and insulator. Okay, or like I said just now, it can flow electric, but it's not good as a conductor. Okay, or you can put the meaning semiconductor is material has a resistance between conductor and insulator, so it's in between. So what is the example of the semiconductor? Okay, so it's a germanium and also silicon. So this is a two type. Okay, the two type of the semiconductor elements. Okay, silicon and germanium. Okay, so this is the periodic table. So I think you already familiar to see this one in chemistry, right? So silicon and germanium are in the group 4 in the periodic table. So group 4 is here, right? Group 4, silicon. Hmm, group 4. Yeah, here, right? I cannot see. Where is it here? Carbon, silicon, germanium. Sorry, my chemistry is not that good. It's a group there. If group 4 means is here, right? Yeah. But never mind, you can see it on your own. Okay. Doesn't matter. So just know that silicon and germanium, and also the picture also is not that clear. Okay. So silicon and germanium are in group 4 in the periodic table. Okay. So means the electrovalence is 4, right? Means there is 4 electrons outside. Okay. So after that, okay. So this is the silicon, right? Okay. What can you say about the number of free electrons in semiconductor, and what can you say about the resistance of the semiconductor? So the number of free electrons in semiconductor is less than those in a conductor. Okay. So you see at the number of free electron in semiconductor is less. Okay. So here maybe got the yellow one, right? We just calculate the yellow one. Okay, so 1, 2, 3, 4. Okay, but this one conductor they have more. Okay, they have more free electrons. Okay, so the number of free electrons in semiconductor is less than those in a conductor. Hence, semiconductors has higher resistance than the conductors. Okay, so they have a higher resistance than the conductors. Okay, because they have a small amount of the free electron here. Okay, so like I said just now, because the silicon and germanium is in group 4, right? So mean they have 4 electrons in the outermost shell of silicon atoms, mean the electrovalence is 4. So when each silicon atom share its 4 valence electron with another 4 valence electrons of other silicon silicon atom, a perfect covalent bond with no free electron is produced. Okay, so let's say this one you already know, right? For each how do we say this? for each orbit, right, they need to have 8 electrons to be, to be stabilized, right, that to be stable. So then now when this one is silicon is 4, germanium is 4, so 4 plus 4 is 8, right? So they can form a perfect covalent bonds with no free electrons. Okay, so that happen when we try to share the silicon and also the germanium electrons. Okay, so at low temperature, at low temperature, at low temperature, a poor silicon is an insulator, right? Mm. Okay. Okay, at low temperature, a poor silicon is an insulator because there is no free current to conduct, free electron to conduct the current. Okay, so when it's low temperature, the silicon here will become an insulator, means the current cannot flow. Okay, because there is no free electrons to conduct to conduct the current. Okay, but the resistance of the semiconductor at low temperature is high. So the resistance of the semiconductor here, silicon and germanium, okay, will be higher at the low temperature. Okay, so what happened at the high temperature? So at the high temperature, a poor conductor with a poor silicon will becomes a conductor. This is because some of the electrons have sufficient energy to break away the bonds and become free electrons. Okay, so just now when the low temperature, okay, there is no free electrons there. Okay, but when at the high temperature means you give heat energy to the silicon, right? So then the electron will gain the energy from that. Okay, so when they gain enough energy, right, so they can break away from the bonds and become the electrons, become the free electrons. So the resistance of the semiconductor at high temperature is low, right? And the frequency that a free electron creates is called a hole, and it is a positive charge. So the place that let's say I have an electron here, right? Okay, then the electron gets enough energy, okay, from the heat energy that you supply, so it can let go itself. So here they become hole, and this hole is a positive charge. Okay, this hole is a positive charge and we call it as a hole and it's a positive charge. So remember, if the low temperature, silicon will become insulator, alright, because there is no free electron. But then when the high temperature, okay, it become a conductor because the electron there can gain the energy from the heat, and to break away from the bonds and becomes the free electron. So the free electron is actually the one that can transmit the current there. Okay, so the resistance is high at the resistance of semiconductor at high temperature is low. Okay, and then the vacancy, the place that the electron leave, okay, then it become hole and it will have the positive charge. Okay, so we already know now, okay, there is two type of charge, right? So let's say this one we only discuss at the high temperature, okay? So there are two types of charge carrier in the semiconductor, okay? The one is hole, okay, that is a positive charge, and another one is the electrons, okay, the one that can, that break away the bonds, right, that can let go itself from the bonds, okay. So there we have the electrons there, the free electrons, and the place that they live there, the shell there, you call it as a hole, a positive. Okay, so this one negative, this one positive. Okay, what will happen if a potential difference is applied across a semiconductor? So semiconductor, two types of semiconductor, silicon, germanium. Okay, then what happens if we apply a potential difference? It means we apply a current to it, okay, a voltage. So what will happen? So the free electrons, okay, the free electrons are attracted to the positive terminal. Okay, so the free electrons are attracted to the positive terminal. So the free electron, just now we have a free electrons, right? When you supply the energy there, then they can break away from the bond, and after that, there will, free electron, they can move, right? So the free electrons, okay, the free electrons will go to the positive terminal. Wait, we have, maybe we can rewind that one. Okay, so the free electron are attracted to the positive terminal. Okay, the valence electrons in the neighboring atoms are then pushed to occupy this hole. Okay, so actually what happened here, right? So this one, it goes to the positive terminal. Okay, so you see the neighbor atom, okay, then we the push, okay, to occupy those holes. Okay, so there we go first. Okay, right. All right, but wait, but in the process create other holes which will later be occupied by other electrons. So they will keep, occupied the hole. So the movement of electron is the opposite direction as the movement of holes, right? So the movement of electron and holes contribute to the flow of electron. Okay, so I just see again, right? The 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 diagram here. Okay, first the electron, the free electron will go to the positive terminal. Okay, now then the valence electron in the neighboring atom are then pushed to occupy this hole. So it moves. Okay. But in the process, create other holes which will later be occupied by other electron. So this one, you can see there's a one hole here, right? That is not replaced. Okay, so then they can say here a movement, but in the process it create other holes which will later be occupied by other electrons. So this hole later will be occupied by other electrons. So movement of electron is actually the opposite direction as the movement of holes, right? So you can see when electron move, this one, they say this one is the free electrons go to the positive side, right? Okay, so then it occupy. So the direction is, the electron direction is to the left, right? Because it need to occupy the hole there. So it's on the left. Okay, okay, it need to move on the left. Okay, but the movement of the holes, okay, you see the holes actually at this side. Okay, so from here it move, okay, it move, the electron field to the next holes, right? So the movement of electron is on to the left. Okay, so the hole actually will become to the right. So the movement of electron is opposite as the direction of movement of holes. Okay, so we already proved that. Okay, the movement of the electron, so the electron is actually moved to the left way because it need to occupy the holes, right? But the holes is will move on the right way because when you leave, right, when you leave the side, okay, when you leave this side, so this one become hole, right? And then this one leave the side, this one become holes. Okay, so the movement of holes at this side. Okay, so it's actually opposite. So the movement of electron and holes contribute to the flow of currents. Okay, so that's why the currents flows, okay, in the semiconductor. Okay, the electron move in one direction and the hole move in the opposite direction. Actually, the hole is not moved. Actually, because the hole is still there, but the hole is like it feels, that one, the electron leave the hole then go to the left side. So this one will become hole, right? But the hole will stay there. It will not move. That's why you put the sign there. So the electron move in one direction and the holes move in the opposite direction. The movement of electron and holes contribute to the flow of current. Since the number of electrons and holes in the poor semiconductor is low, thus its ability to conduct the electricity is also low. Alright. So even like we know they can produce a free electron, okay, but it's not as much as a conductor, okay, as a metal. So the ability for them to conduct the electricity is low. They can conduct, but it's very low. Okay, we compare with the conductor. Okay, because of the free electrons. Okay, because of the free electrons. Alright, so increasing the temperature of the semiconductor, the heat supplied by the temperature increase is converted to the kinetic energy of the electrons. So if you increase the temperature of the semiconductor, means you increase the heat energy, right? So the heat energy will make the temperature increase and it will convert to the kinetic energy. So that's why it can break away from the bonds, okay, from the bonds uh, of the atom there, right? Of the electrons there. Because the energy, okay, give the heat energy can convert to kinetic energy, mean there will be vibrate. Okay, then after that, it will snap and then they can move away, and then that place they leave become holes, and that will become free electron. Okay, so adding impurities to the semiconductor, okay, is we call it as a doping process. Okay, impurities. So maybe we can add something, okay, to the semiconductor, okay, to increase its conductivity. Okay, to increase its conductivity, we can add impurities. So this process, okay, you adding the impurities into the semiconductor, we call it as a doping process. Okay, a doping process. So what is doping process? So doping a process of adding impurities to pure semiconductor, whether it's silicon or germanium. Actually, another type of semiconductor, but usually we know it's a silicon and germanium. So doping is a process of adding impurities to pure semiconductor to increase the electric conductivity. So mean it can conduct electric much better. So the atom of the impurities added should have the same size as the atom of the semiconductor. So they need to have, if you want to dope the semiconductor, you want to do a doping process to the semiconductor, the size of atom need to be same. Okay, the atom, the impurities need to be same. So when we do the doping process, okay, after we finish the process, the doping process, you will get N-type semiconductor and also the P-type semiconductor. Okay, so you will get two type of semiconductor after you finish doing the doping process. Okay, we can get n-type semiconductor and p-type semiconductor. So how, which one we know that we can make n-type or p-type? That one you need to know what type of the impurities that you added. Is it the three trivalence, okay, trivalence, or you have a 5 electrovalence? That one it depends. Okay, so you just need to know there is a doping process in you adding the impurities inside the semiconductor to increase its conductivity. So after that, you can produce two, whether N conductors on N-type conductors or P-type conductors. Okay, so just now I told you, right? Whether you want to produce the N-type or or P-type semiconductor, okay, you need to know the material or the atom that you use to do. Okay, what is the equivalence? What is the equivalence for the atom, and also the size must be the same, right? Okay, N-type semiconductor. So we already know the doping process will produce the N-type semiconductor, P-type semiconductor. But then how we know we want to produce N-type, then what should do, what we should add to the semiconductor? Okay, so for the N-type dope poor semiconductor, okay, this is the bottom part. Dope poor semiconductor with pentavalent atom. Penta means 5, right? Pentagon means 5. So mean pentavalent atom means they have 5 electron valence to produce an abundance of electron in the semiconductor. Remember just now, right? Silicon, they have 4. They are 4 electron valence, correct? So 4, and you dope it with the pentavalent valent atom. So 4 plus 5 is 9, right? So you already know each orbit can only contain 8 electrons. So there is one free electron there, right? So one free electron, that one will become free electron. Okay, so that is that we increase the conductivity, right? Okay, so that mean there is more free electron there. Okay, that produce n-type. Okay, and also you can know by n. N is a negative. Let's say it's just we assume n is a negative. So negative means it has to have more electron. So in order to have a more electron, silicon or germanium, there are 4 electrovalence. So if you say you want to produce n type, means the negative, the electron more, there is more electron. So you need to dope with 5. So 4, 5 times plus 5 is 9. Means there's one free electron there. But if they say you put 3, 7, then there's not enough electron. There is no free electron, but there will be hole there. Alright? Okay. So that is a N-type semiconductor. Okay. P-type semiconductor. Okay. For P-type semiconductor, okay, you have to drop the poor semiconductor with trivalent atom. Means they have 3 electron valence. So 4 plus 3 is 7. Is it enough for the one orbit? No. We know that it's actually, if you want the orbit is want to be stable, you have to put 8 there, right? So means there's not enough one electron, so they will produce an abundance of holes in the semiconductor. Because it should be 8, but 4 plus 3, 7 only. So one place, like there's one place is empty there, okay? That one will become holes, okay? So there's a lot of holes there, okay, inside the semiconductor, okay? This is what happened when you doping, okay? Doping means you edit the impurities material, okay? So what type of impurities is up with the at the pentavalent atoms, trivalent atoms, that will produce a different types of semiconductor. N-type must from the pentavalent, mean 4 plus 5, 9, 1 extra electron. So that one become N-type, negative, right? But then P-type positive, and the whole you already know the charge is positive, right? So 4 plus 3 is 7. So you don't have enough 1 electron. So means you will have the positive charge there. Okay, the aspect. Alright, so now the poor semiconductor, silicon, germanium, the N-type and P-type, they can use both silicon and also germanium. Okay, for the dopant material, so what is the dopant material that can you use? What type of impurities that you can use to produce the N-type? This one you need to remember. Okay, they will ask you, let's say sometimes what type, let's say you want to produce N-type or P-type. So what is the dopant materials that you need to put? Okay, so for the N-type, you have a phosphorus, arsenic, and antimony. Okay, there are 3 types of the dopant materials. If you want to produce the N-type semiconductor, okay, you can use phosphorus, arsenic, and antimony. So whether you can dope it with the silicon and phosphorus, or phosphorus with germanium, arsenic with silicon, arsenic with germanium, is either one. Okay, you have to choose. Okay. And about the P-type semiconductor, okay, for the P-type, silicon and germanium also, okay, of course, there is the poor semiconductor, and you can dope it with the boron, aluminium, and also a gallium. So this is the material or dopant material that you can use to produce the P-type semiconductor. Right? So this one means dopant materials is actually this one, the 3 of it have a what? Have a pentavalent, right? Pentavalent. Okay, and this one is trivalent. Okay, so what is the function of the dopant materials? So the dopant materials, since they have the phosphorus is the pentavalent, right? So means they have extra electron there. So they will become a donor atom. Okay, they donate the electron there. Okay, but for P-type electron, okay, it's a acceptor. Okay, for the function of the dopant material is just to accept the atom, because they don't have extra electron there. Okay, so just accept the atom. Okay, and the valence we already discussed. For N-type, pentavalent. For P-type is trivalent. Alright, and the majority charge carrier. So inside the semiconductor that we produce after we doping, what is the majority charge carrier? So if the N-type means there's one extra electron there, right? So there will be a lot, not like just one. Actually, it's just a lot of free electron there. Okay, so the majority charge carrier is the electron because they have a lot of there. Okay, they scattered everywhere. Okay, but for the p type, since they don't have enough electrons, okay, it's actually 8, right? But now they only got 7, so there will be not enough the electron, so there will be more holes, right? So more holes mean there will be has a positive, right? So that one is an electrons negative, this one the holes will become charged positive. So the minority, of course, if the electrons is the majority, the holes will become the minor. If the majority is the holes, the minority will be electrons. Okay, so we just doing a quick review. Okay, semiconductor. What is a semiconductor? Semiconductor is the material, right? Is between the resistance is between the conductor and also insulator. That is a semiconductor. Okay, so there are two types of semiconductor, silicon and germanium. Okay, so silicon, they have 4 electrovalence. Okay, they have 4 electrovalence. Okay, and then after that, we can increase the conductivity because we know semiconductor, it can conduct electric, but it's not that good. But we want to increase its conductivity. We want it to make the current can flow through it much better. Okay, so the silicon and germanium, okay, we have to do one process, okay, so it can increase the conductivity. So we do the doping process, right? What is the doping process? Doping process is the process that you adding the impurities into the semiconductor, that is silicon and germanium, to increase its conductivity. Okay, so after we doing the doping process, you can produce two type of semiconductor, N type or P type. Okay, so for the N type conductor, you have to doping it with with a pentavalence atom. Okay, means they have 5 electrovalence. Okay, we know silicon germanium is 4. 4 plus 5 is 9. So they got one free electron. So one free electron you already know is the charge negative. So that will produce the N type semiconductor, negative. Okay, but for the semiconductor, okay, for the P type, they say we want P type. So if you want P type, you need to dope the silicon or germanium. Silicon or germanium is actually the base thing. Okay, the base thing means you cannot change it with other thing. Okay, it have to be silicon or germanium. So silicon and or germanium, okay, you dope it with the trivalence. So 4 plus 3, you got 7. Mean there's one holes not, there's one holes there, right? So when one holes there means there are P type because holes the charge is positive. Okay, I did told you just now. Holes is a positive charge and the electron of course are negative charge. Okay, so that what we learned until now. Okay, N type and P type. How does it produce? Okay, but then why we need to do all this? Why we need to have an N-type semiconductor, P-type semiconductor, right? What is the function? That one is actually to make the component, the electrical component that you use, such as a diode, transistor. Okay, so these two actually are using this N-type and P-type semiconductor. Okay, because we want to make the electrical component. Okay, because I think you learn in I think RBT or something, that what is the function of diode? Diode is only allow the current flows in one direction only, right? And the transistor, yeah, they can be as a switch, as an amplifier, okay? So it depends. Okay. So that thing is very important. Okay. They say and diode is very important to change from AC to DC. Okay, because not all the electrical appliance need to use AC. Some of them have to use DC. So how does we convert it from AC to DC? That we will learn in this chapter. Okay. All right. So already finished. Describe the function of the semiconductor diode. Okay, the transmission of the electrical power to consumer through a network in the form of AC. So this one we already know, right? From the power, from the tempat jana kuasa. Sorry, I forgot in English the words. Okay, so for the electrical power to consumer through a network in the form of AC. So we know even like in our house also we will receive the voltage in AC current. So however, in everyday life, okay, many electrical device can only function with direct current. So this one I just told you just now. So therefore, the AC need to be converted into the direct current. Okay, so this is a diode. Okay, and this is the picture of the diode lah. But then you cannot draw this one. If they ask you to draw the schematic diagram, okay, we have to use the symbol. Okay, we need to remember what is the positive, what is the negative. This one is very important. This one is for forward bias, reverse bias. Okay, then you want to, let's say there's four diodes. The four diodes. You need to put the four diode there. One diode. Right? So that one you need to know positive, negative, because we have to forward bias the current can flow, reverse bias the current cannot flow. Okay, so you need to know this part is a negative and this part is the positive. So what do you think actually happen at this diode? This is actually the combination of the semiconductor of P and N. P is positive, mean at this side, okay, and N is the negative, so at this side. Okay, so positive, negative. Please remember which part is negative, which part is positive. All right, this is very, very important. All right. Okay, now we learn about the function of the semiconductor diode. All right, forward bias and reverse bias. Okay, so the first thing, like I say, when you got the diagram of diode, please label the charge. Negative, positive, negative, positive. Okay, and then you have to know that if we connected, okay, we connected it in the forward bias. Okay, if forward bias means the current flows, it will be the bulb will light on, right? Okay, the positive must be connected to the positive. Okay, the positive terminal of the battery must be connected to the positive terminal of the diode to produce the forward bias, means to allow the current flows. Okay, if you put it wrongly, let's say you put this one, you change the terminal of the battery. Okay, you connect the negative terminal to the positive one. So this will become reverse bias. The electron will not move, the current will not flow, the bulb will not light up. Okay, the bulb light up only for forward bias. Okay, so positive to positive. Okay, alright, and then the current flows. Okay, this is a symbol. Okay, so I already teach you, okay, how for the forward bias. So remember, positive terminal to the positive terminal, negative terminal to the positive terminal, it will not be working. Okay, then sometimes they ask you, how to make, let's say for the objective questions, right? They give you a diagram, so they say why does the current why does the bulb is not light up? Okay, so you see the current is, they put the diagram like this. So you say because this is in the reverse bias. Okay, because this one is a reverse bias. Or sometimes they will, you can say because the terminal of the battery, okay, is being connected to the positive terminal of the diode. Okay, so you can answer by using that answer. Okay, so forward bias, reverse bias. Okay, what is the function of the diode? Allows currents flows in one direction only. Okay, actually for this one, of course, this is a DC, right? This is a dry cell. Dry cell, of course, there will be flow on one direction only. Okay, and a state when the condition when a diode allow for current to pass through it, forward bias. if the drive cell is changed to the alternating current power supply, what will happen to the bulb? Okay, so the bulb will light up and light off alternately. Why? Okay, so I remember when I told you, right, this is the symbol of alternating current. Okay, so let's say I have a diode here. Okay, and I have a bulb here. Okay, it's connected. Okay, I put the terminal first, the symbol. Okay, so they have a two cycle there because alternating current they keep change the direction, right? So let's say first part positive negative. So positive here goes here, right? Goes here and go there to complete one cycle. Alright. So from the alternating positive terminal makes a positive. Positive is a forward bias. Remember? Right? Positive forward bias. So the bulb will light up because forward bias. But then when you change the pole, when we change the terminal, now it become positive here, negative here. So the positive will be connected to what? To the negative terminal. So it will become reverse bias. So reverse bias, the current will not flow. Okay, so it will be like, okay, sometimes like up, sometimes not, sometimes like up, sometimes not. All right. So we don't want that. Okay, of course we don't want our home to be, that the light sometimes on, sometimes off, sometimes on, sometimes off, right? Okay, so that will happen if you change it to the alternating current. So we don't want that. So we have a a solution to that. Okay, we have a solution to that. I'm not sure. Okay. This is the last slide. And tomorrow no class, but Monday as usual at 10. Okay, and then tonight. Okay, so whoever are free, you're free, you can join the class. Okay, so they say you're outside, so you can join using your phone, right? You just need to hear because we will just discuss. Okay, we just discuss. I want to do revision with you. Okay, all right. So how a diode is produced? So remember I said what we function we do the semiconductor P type, M type, right? So a diode is actually to make the electrical appliance such as a diode because a diode is a joining a P type and the N type conductor. So that's why we need to produce the P type and N type semiconductor because we want to make a diode. Alright. So a diode, what is the function of a diode? Diode is a device that allow current to flow in one direction only. So means the alternating current can be changed to direct current by using a diode. Okay, but there is a arrangement for that. Sometimes we can use one diode or four diode. Okay, that one we learn later. Okay, rectifier. Okay. Um. Alright, so I think I will stop the class now. Okay. I see you on tonight. All right. Okay. So take care, everyone, and thank you for joining my class. Okay. So see you tonight. All right. Okay. Take care, everyone. Bye. Welcome.